dog. In these terms, how does that, how do you imagine the implementation? This attraction, it's an attractor.
I imagine a node with a concept dog, and I imagine another node with a word dog, and I imagine a link between them, which is a meaning link. See, one meaning of the word dog is this concept dog, but there are other meanings of the word dog as well. You know, so you have this concept dog gets mapped down to some attractor. This concept word dog gets mapped down to some attractor. The link between the two of them gets mapped down to the coupling of these two attractors, of these two oscillators, the coupling of these two oscillators. And that's where the meaning comes from. That's how the word dog gets attached to.
And the reason you're thinking of this in dynamic systems terms is important is that this node, or these nodes and these attractors are not in a particular place. They are in fact a distributed product.
Well,
very broad scale activity.
Yeah, but they do have some idea. You won't find cell assemblies for a word node down in the cerebellum. You're likely to find it up in Wernicke's area, aren't you, or that kind of thing.
IT.
But I would imagine from what
No, I'm
you're
talking
saying
about not the concept. I'm talking about the word.
The word, yes.
Word.
Wernicke and Roca.
Yeah.
But even there, what I would imagine, what I imagine from what you're saying is that you wouldn't be expecting to find a location exactly, although you might, the activity associated with
Not for the whole concept.
Yeah.
But you can find one area that would be associated with visual recognition, another area that would be associated with verbal recognition, and I guess the hypothesis would be that the node would be sort of implemented over any relevant areas and probably in ways that can't be expressed in areas also. I think it's kind of...
I'm imagining that actually, from what you said, that it is actually some kind of pattern of oscillation that is the meaning of the word, in some sense, the way you're talking about it, rather than being a location.
An oscillator is going to be somewhere. It's going to be a cell assembly, and it's going to be the trajectory of that cell assembly. And then you've got the other one is going to be another cell assembly and its trajectory.
You don't have to think of assembly in a localist way.
No, it can be. It doesn't have to be localist. It can have two pieces far apart.
Well,
yeah.
It's many pieces.
There was a paper, a BPS paper on local and distributed models, and what did we say we were localist distributed? I mean.
So I think
You're a compromise type.
So I'm trying to imagine this too, and would it be enough? So what I'm thinking of is the binding problem, right? And how you bind features together. And some theories say, well, there has to be a way for these things to be bound together for consciousness. But couldn't it just be that they happen at the same time?